Good evening, folks. This is a problem I wanted to tackle, and this is using power rules to sort of the nth degree. This is a pretty big problem that was assigned to my 10s. It was taken from a worksheet that they did. This was question number 30. So for this question, what I'm going to do is I'm going to simplify this as far as I can, applying all the power rules. Remembering that in a final solution, in a simplified version of these, I want no negative exponents when I'm done. All right, so where should I begin? Well, to start with this, the first thing I'm going to do is I'm going to simplify this 2x to the negative 4 y to the 4 z squared all to the power of 4 first. So in order to do that, the first thing I'm going to do is I'm just going to write down my numerator, and this first part of the denominator, I'm just going to put those down here without touching them. So just copy them straight down. I'm now going to tackle the second part. And for the second part, I'm applying what is called the power of a power rule. So I'm going to multiply each term in this polynomial, or this expression here, by 4. So put 2 to the power of 1 times 4, and that's going to give us 2 to the power of 4. X to the power of negative 4 times 4 is going to give us x to the power of negative 16. Y to the power of 4 times 4 is going to give us y to the power of 16, and z squared times to the power of 4 is going to be 2 times 4, which should give me z to the power of 8. All right, so I've simplified that first. My next step is I'm going to combine or multiply the two terms in the denominator. So once again, I am not going to touch my numerator. I'm simply leaving it alone. I'll deal with it later. And now I'm going to multiply. So the first thing I'm going to multiply is 2 times 2 to the 4, and I get 2 to the 5th. X squared times x to the negative 2. I keep my base. I add my exponents, so I end up with x to the negative 14. I do the same thing, y cubed times y to the 16th. I multiply the same base, the like terms, keeping the base and adding the exponents, and I get y to the 19. And the last part is z to the 4 times z to the 8, keeping my base, adding my exponents, z to the power of 12. So now I've got everything on the bottom simplified. The top had no simplifications, so now I'm going to work top down. So to simplify using my quotient rule, I have no standalone number save 1 on the top, so all I'm going to do is write this down as a fraction and leave my 2 to the 5th alone on the bottom. My next step is x to the negative 3 divided by x to the negative 14. I keep my base of x. I subtract negative 3, subtract 14, and I get x to the power of 11. Now I've got no y's on the top, which would signify a 1. 1 divided by y to the 19 is just 1 over y to the 19. So I just write y to the 19 on the denominator. I deal with my z's, z to the 4th divided by z 12th, keep my base of z, subtract my exponents, and I get z to the negative 8. I'm almost done at this point. The next step for me is to take the negative 8, because I'm not allowed to leave a negative as an exponent, and I'm going to reciprocate that to 1 over z to the 8th, or effectively, I move it to the bottom and make my exponent positive. I also need to simplify the 2 to the 5. So I leave my x to the 11 alone. My 2 to the 5 becomes 32. My y to the power of 19 doesn't change. And my z to the negative 8 moves down and becomes z to the 8. That's it. That's how you would simplify that. So my final solution is x to the power of 11 all over 32 y to the 19 z to the 8.